A key component of the modern world economy, the chemical industry delivers products and innovations to enhance everyday life. It is also an industry in transformation, where chemical executives and workers are delivering growth and industry-changing advancements while responding to pressures from investors, regulators, and public opinion. Discover how leading companies are approaching these challenges here on The Chemical Show. Join Victoria Meyer, president of Progressio Global and host of The Chemical Show, as she speaks with executives across the industry and learns how they are leading their companies to grow, transform, and push industry boundaries on all frontiers. Here's your host, Victoria Meyer.
Hi, this is Victoria Meyer. Welcome back to The Chemical Show. This week, I am speaking with Stephen Reynolds, who is the industry principal for the chemicals segment at AVEVA. He's an operations guy who has spent the first part of his 25-year career in manufacturing sites for companies including Roman Haas, Sunoco Chemical, and SunCoke Energy before moving to the corporate side of the house. Today at AVEVA, he combines his operations insights with digitization to help companies achieve and improve operational excellence. Stephen is based in Chicago and is an alumnus of two of my favorite universities, Texas A&M and Loyola University Chicago. Stephen, welcome to The Chemical Show.
Victoria, thank you for having me, and thank you for that very excellent introduction.
Oh, you're welcome.
I'm about to keep some of that.
Yeah, there we go. I'll send it back over to you. What's your origin story? What got you interested in chemicals and what really got you into operational excellence?
All right. Well, those are two separate things, really. And you know, from I'm using some school buzzwords that I hear from my daughter. You know, the STEM professionals typically can trace their roots back to a teacher or a school experience. And so I think I can do that. So I grew up in Lubbock, Texas, which may not show up on many maps that people recognize, but we had excellent access to just a tremendous education. And I can say that I just finished a high school reunion, and we got together and talked about, you know, the experience that we had, and I can trigger, you know, the beginning or point to the beginning of my chemical engineering adventure down to my high school chemistry teacher. You know, Mr. Aiken, if he's listening, thank you. But, you know, Mr. Aiken was one of those teachers that got you involved early and often and really just honed your skills every day. And I ended up taking 2 years of chemistry in high school, so that by the time I got to college, it was a real no-brainer. And I can remember, you know, Mr. Aiken saying, hey, you know, chemistry is great. You're great at it. You should try engineering, and because you can go far in that. And, you know, 25 years and counting, here I am.
Yeah, that's pretty cool. That's pretty cool. So,
and from an operational excellence standpoint, kind of very similar, but it falls more to the leadership that I've been exposed to and the time I've had around them. You know, my first plant manager, we were in a small polymers plant in Southeast Texas, and you know, we loved firefighting, that firefighting mode, the you know, that hero aspect of always solving the problem today. And you know, he liked to really focus on the difference between firefighting and excellence, and how do you go from one to the other. And you know, the other people have called, you know, firefighting that catch and release improvement plan, where you find an idea and it's gone the next day because you're moving on to the next fire. And so we really started to preach, you know, solving those problems, establishing the operation systems to really facilitate moving from firefighting to excellence, so that you didn't repeat the same fires every day. It's fine to firefight, let's just fight different fires. And you know, I ended up working for the man 3 different times. So first as a unit engineer, I got involved in his operational excellence operating discipline program at another company, and then followed him finally to SunCoke, and where I did continuous improvement. So obviously he made an impression, and I've tried to carry through.
That's interesting. I know, in fact, it was during my manufacturing days that I also got exposed to operational excellence the first time. We didn't call it that. I was an operations manager in charge of a polyethylene unit, and I was leading a reliability team. So our plant manager had implemented a bunch of reliability teams. But again, it's all about getting to the root cause, about not repeating the same issues, about achieving a higher level of performance and excellence in performance. So that's really interesting. Tell us a little bit about AVEVA.
All right. So I had to write this down so I didn't get it wrong. But, today, AVEVA is a wholly owned subsidiary of Schneider Electric. And so that gives us, kind of the width and breadth behind us to really do great things. AVEVA has a broad portfolio, almost an incredibly comprehensive portfolio that can help our customers manage their information and data from the beginning of engineering and design through on to the run and maintain of operations, the training of our personnel, and then finally to optimization and sustainability. So it runs the spectrum of those tool sets and customer needs. So I think we're a global company, so we operate on all continents, with maybe the exception of Antarctica, obviously. But so we support and implement and guide our customers, hopefully, to success.
Yeah, that's really cool. That's cool. And I am familiar with a few of AVEVA's products, but maybe we'll talk about some of that later about where that comes in, because I think there's a lot of buzz when we start talking about digital and digital operational excellence, which is one of the things we're going to be talking about today that we can maybe demystify or talk about a little bit more.
All right.
Awesome.
Yeah. And then, AVEVA has grown through not only, organic engineering and design of their products, but through acquisition as well. I joined AVEVA from OSIsoft, which is the makers of the Pi system, which has been around for over 40 years now, and I've been a customer of which for at least 20 of those. And so it's that blending of technologies, building on the foundation of data, and then adding those other applications that AVEVA can provide to really build that comprehensive suite of tools, to help our customers.
That's interesting.
Really
And I had not appreciated that, how old some of the AVEVA technology is, as you say.
Yeah. Yes, ma'am.
Interesting. So you started your career in chemical manufacturing, and now today you help manufacturing companies. How has the industry's approach to operations and operational excellence changed over time?
Well, I would say we've definitely gotten leaner. Even from my early experience, I hired into an engineering staff of maybe a dozen professionals, and through various initiatives and departures, whittled that down to one.
Wow.
Which is very difficult to comprehend as a young engineer. Not everybody is that extreme, but I think that's a growing refrain within the industry. We can't staff the way we once did, and so remote resources may be remote, they may be external, and how do we manage the flow of information across those boundaries to get the best answers to our people? And I think that flow of information is what's changing quite a bit. It's no longer a kind of dribbled out on a need to know basis. I think leadership is beginning to open some of those gates and sharing real information and insight with our teams, and that's really there hopefully to drive decision making to that point of action, so that we give people the information they need to make the right decision when they need to make it, and they don't have to always run it up the leadership chain to get approval, permission. They're empowered to act. And I think as we see the role of technology there's an initiative called the Connected Worker, and that's really we're going to talk operational excellence and digital transformation, and it really comes to a point at that connected worker piece, because we've managed our people, process, and technology to a point where they're at the tip of the activity, driving the business.
Yeah. All right. So let's talk about connected worker, because I do hear that term periodically. When that term is used, when we talk about connected worker, is that about the operator at the site, or who does it really refer to? And then how does it manifest for them to be connected?
I think certainly it does drop to extend all the way to the shop floor. So the operators in the field, the growth of augmented reality tools and virtual reality tools can give them that overlay of information. Of course, that's the future state, or the leading edge technology right now. But even so, the handheld devices have access to information so that they can go out to a piece of equipment, get the work history on that, get the current state of operations from not only the field gauges that they see, but from the sensors that are coming into our control systems. If there's other analytics involved, we can arm them with the tools they need when they're out in the field. So, access to procedures, access to troubleshooting guides. They don't have to call in, hey, what do I do next? Or, it's just right there at their fingertips. And similarly, with our control operators and even our engineers, COVID inspired us or pushed us into this remote technology age where we can access data from just about anywhere. I mean, I can remember as a young engineer being the on-call engineer, over the weekend or the week or the holiday, and having to get this bag full of this archaic laptop that had to dial into the network to get access to the data, right? And now all that's available from our phone, provided we can set up the cybersecurity. So your expertise can be remote. We have several instances where our customers are building these remote centers to help optimize, so their connected workers, the plant may be in Houston, their expertise might be in Ohio. And how do we bridge the gap of the information that needs to be sent? So
yeah, that's interesting, because I think it used to be when people started talking about and started actually building, let's just say, central control rooms, or having, if you will, control rooms remote from the site, which it sounded like implausible. It sounded
yes.
Unsafe. It sounded risky from an operations perspective, from a safety perspective, from a responsiveness perspective. And yet, as you say, technology has really accelerated and made that possible. And I guess the experience that we've all had of working remotely as a regular piece of our business has changed our mindsets as well.
Yeah, and that will suit our upcoming generation of chemical workers, whether they're operators or engineers or part of the business team. My daughter's 12, and she's on her phone 24/7, and that's just how they interact with people and information. So that won't even phase them when they get into industry.
You're right. You're right. So they want, I occasionally, in fact, even this morning, I printed out something so I could do some edits and do some thinking, and my kids don't do that. They do their thinking on their devices or on electronically, and they have just a different comfort level.
Yes, ma'am, for sure.
Yeah. Awesome. So, we started talking about the whole digital transformation, and really there's been an element of digital in manufacturing for years. So, I mean, I think back to even my time in manufacturing, which was a long time ago, as it turns out. We had DCS systems. We talked about statistical process control as a way of managing data. So this has been around for a long time. What's different today? We've talked a little bit about the connected worker, but is it beyond that? What's really different, and how has it evolved?
Well, I have similar experience. That first plant I worked at, I came in just as they were going through a DCS conversion, going from their their old pneumatic wall of pins to a DCS. And, I had operators swear up and down that they could look at that wall and know exactly how the plant was running. It had been in existence for probably 30 years at that point.
Oh my God. I
so
remember seeing walls like that and having
Yep.
no idea how they were controlling anything.
So,
Yeah.
and so that was my first exposure to that transformation. And within 2 years at that plant, a controls engineer came and was beginning to develop that advanced process control, and operators were embracing it. So the pace of change is very fast, even with, senior people. They realize the facility of it, and off we go. And I think really that's what's changed in the digital age that we're in, is that rate of change and the access of technology. As the saying goes, back in my day, spreadsheets and the use of Excel was the height of innovation in those early years, right? We had data historians that could connect the DCS to our spreadsheet. We could get our data, manipulate it, do all the analytics, and go. And that was considered pretty robust at the time. Now our real-time data systems take those analytics, put them into the system, manage them, and then we begin connecting the dots. And we'll talk about digital twins and things, but we're creating that digital representation of our assets, our plant, our business, so that information begins to connect and relate to each other, and we can scale it out and manage the information so that people can step in and work and understand what's going on and have access to key decision points. And so the technology, you might hear a phrase, edge to cloud. For a long time, we resisted adding more sensors because we didn't have enough control points in the system, right? Well, if it's not needed for control, we can strap on these sensors now and farm the data up to the cloud, or remote access into, for example, the Pi system or other historians. So the data is there, and it's fairly inexpensive. And so you're seeing more and more access to information that we've not always had. This improves field data, gauges. Now, we have the barcode systems where we could ping something and up comes the data into our handheld, and that can go into our data systems. So I think the access to data is crucial. The rapid advancement in our ways of analyzing things is what's really impressive. The pattern recognition, the AI, the predictive analytics. We sell those today. I've never used them personally. I've walked through demos.
Yeah.
I've interacted with the software, but I've never had to do it. We've always had to go, like I said, from the historian to the spreadsheet to try to run those predictive algorithms ourselves. And now those tools do it in real time, and we can see where we're headed weeks, days, months, hopefully, before we get there. And I think that's really crucial. And like I said in the beginning, I'm a longtime customer of the Pi system, and for me, and I'll probably get in trouble for saying this, as a young engineer, all these different systems were relatively interchangeable. Data historians were just a way to get data, and I think what's really imbued these systems with power is that digital twin. And I think for me, that's been the real aha over the last 10 years or so, of being able to contextualize the information and how it relates. This helps us build, standard templates and analytics so that it's no longer, plant A's version of the truth compared to plant B's. We have that common language. We're starting to build that single source of truth that we always speak of, so that we can really compare apples to apples. And if there's an orange in there, we know it. And this is how we make that comparison, instead of just trying to feel our way through it.
Okay, so let's talk digital twins. What is it really? It sounds a little scary, and big and I think about assets and how big and bulky they are, and imagine doing this on a digital basis as a digital twin. It's kind of mind-boggling. But what is it, and what value does it offer to the users?
So yeah, that question comes up quite a bit, and everybody has a different definition of a digital twin.
All right, good to know.
And well, in each organization or business unit or business group will have one. If you go into systems, maintenance systems have their functional locations broken down by asset down to the bill of materials, and that's a digital twin. Our real-time systems will have that. We can use that same structure. We can organize it differently based on what we need, by asset, by plant, by region, by business, however we want to do it. Financially, you get into the general ledger, there's different accounts. That's a financial digital twin. HR has their systems. Safety and compliance have their ways of reporting and managing information. So digital twin for me is really just is that representation of how the data relates together, and how do we organize it from these data sources into a meaningful, useful way within our system. And so it's really, we have standard practices or better practices out there, but each customer has their way of organizing their information and connecting the dots through their system. And so we just help them.
We'll be right back. At Ecovist, they're accelerating the transition to a sustainability-driven future. Their long history of innovation, expertise, and customer collaboration supports the development of proprietary catalysts and services across their two industry-leading businesses, Advanced Materials and Catalysts and Eco Services. Advanced Materials and Catalysts is a leader in proprietary and customized technologies for polymers, cleaner fuels, emissions control, and circularity. Eco Services is the largest North American recycler of spent sulfuric acid. Ecovist, your catalyst for positive change.
Get there faster, hopefully.
Yeah, it's interesting. So I envision, so I'll just tell you where my brain goes when I think about a digital twin. I think of it in some ways as, if you're looking at the control system, and on the control board, you can see the different pieces of equipment and the flows and the ins and outs and the pressures and temperatures and all the data that you're doing that. Is it that, or is it much more about decision scenarios?
Well, it starts with that. For example, within our PI system, that's how we might define. You might define a pump, and these are all the digital points that define this pump. We will connect it to our asset information systems to bring in the contextual, the manufacturer data, the control limits, those types of information. So, we'll have what we call a pump, and a number of pumps, compressors, reactors, vessels will combine to form an operating unit, and then the operating unit will combine to form a plant, and the plant's enterprise and beyond. So that's the basic of the data, and then how we use it is really the power of the digital twin. So you mentioned decision making. I think the digital twin empowers or enables rapid dissemination of information. So you're no longer having to look at everything. I can remember those early DCSs where you had to flip every darn screen, and finally we developed that alarm panel or the exception panel, and then so we do the same with the digital twin. We're trying to manage by exception, so that as this data combines, we can see that total picture of whether it's performance around a unit, a business, or an asset. We have the information that says, there's an anomaly here, we need to go act. And so I think that's really the power of the twin, is bringing all this to bear for better decisions back to the connected worker. So we do all this hunting and pecking digitally so that they don't have to. I mean, think about in your engineering days, if you had a problem with a pump, you had to go to the maintenance shed, find the file room, dig through a dusty old filing cabinet that may or may not open without some assistance. Water may have gotten in there, rats, dirt. You're not guaranteed to find the right information. Digitally now we connect the dots so that that digital twin carries forward from your real-time operations all the way back to your engineering documentation if so needed.
Yeah, awesome. So I've kind of got a two-part question. I'm debating which direction to go with it first. So I'm going to start with this one. It feels like a really big undertaking, both from a financial perspective, a people perspective, resources, time, etc. Which then makes me say, maybe start with this question first. How do people justify this? How are companies justifying the investment of time, resources, individuals, et cetera, as they go through this digital transformation?
Well, you hit on the key word, investment. Very often these projects are rolled into a cost center. They're an operating cost or some new gadget that we're trying out. And so they don't see that as an investment towards the future. And that's really what digital transformation is. It's an investment. It's an extension of that operational excellence into that next thing. We've taken people, process as far as we're going to go, technology in our processes maybe as far as we're going to go. Now this added information technology can really push us over to the next phase. And so investment, like you say, it's a resource problem. So the bigger companies, of course, have people and assets to really throw at some of these initiatives, and some of the smaller plants don't. And so it really is, it's change management and identifying that need for change. We don't want to be a solution looking for a problem. And so, part of our trusted advisor goal is to help our customers understand what they're really trying to do, what they need to achieve, and then coming up with the capabilities that they may need. And it's not one size fits all. Not everyone's going to race ahead to that, virtual plant in the sky. Many of our plants, or our customers, just need access to the information, visibility into the process, and they're able to identify 80% of their problems. So I think one is finding that need for transformation. COVID's a great example. We went remote, right? And so people were not always coming in or accessible to the plant to help. How do we solve that? And, people have been asking us about visualization, remote access, and just getting that visibility into the data. So that was a big change, or big need for change. For years it's always been cost driven. I really need access and to optimize our process. So you mentioned SPC, that was driven at minimizing waste and minimizing transitions, optimizing yields. How do we get the biggest bang for our buck within our process? Asset reliability has always been a challenge. So in a lot of these petrochemical facilities, there's big iron out there, or very valuable assets, not iron, probably some specialty monomer or materials and things like that are very expensive to fix, very expensive to repair, require downtime and all that. Enough of those failures pop up, you're going to install vibration monitoring, you're going to install predictive analytics to say, I need to get ahead of these and drive this improvement so that I can stop firefighting and move on to excellence. And so that's where these tools really come in.
Yeah, that's helpful. And in fact, because part of the part two of my question was really, it seems like this is A lot of this digital transformation is really being enacted by the biggest companies with the biggest investment base, the deepest pockets, if you will, and that there's a perception. And when I talk to companies that are mid-sized companies and smaller companies, that it's not for them, that this digital transformation isn't for them, that maybe the value's not there, or the economics don't work, right? Again, when you're working off a smaller investment pool or operating fund, it doesn't feel like it fits. How do you respond to that? What do you see happening?
Well, I mean, you're right. The chemicals industry, especially, is slow to change, and so we see a broad spectrum of technology adopters. The leaders out there. You look at Dow Chemical. They're always Dow, Covestro, BASF. A lot of these big name top 25 chemical companies are out there innovating. Dow. Their goal was to eliminate confined space entry with the use of Industry 4.0 technologies, whether it's drones and virtual inspections, advanced analytics, those type of things. But even they will concede, that they have pockets of excellence. So, they are testing these technologies, improving them out where they can, and when there's, I guess, capability to achieve some of these. But they'll concede that solution is not universal yet, right? They haven't implemented it at the deepest, darkest plant in middle of nowhere, West Texas, for example. When we talk to these smaller customers, that's what we tell them. Hey, yes, there are leaders out there doing these great things, but they haven't licked everything, and their solutions may not be your solutions. And so there's, we like to preach the start simple, but simply start mantra. And I didn't coin that phrase. That came from one of our customers. But
that's a great phrase. I'm making note. Yeah.
But it comes to understanding that need that you have, and back to that managing change. What do you need to do, and what are you prepared and ready to do? So a lot of these technologies require information and data, and some of these plants, we talked to the ag chemical facilities, the fertilizer plants and things like that. They have a low digital footprint because they make low margin products that don't warrant that investment, and they've been doing it for many years well, and so they just haven't felt the need to do some of these things. But they're coming up with new reasons to do this, and that's, like I said, where the edge technology allows that bolt-on sensors. But it really is for the smaller companies and the ones that are just starting their journey, is find that investment need. Start small, think big, but start small. Fail small is another great tagline that I've heard. So you can explore the technology, invest in quick wins, demonstrate it, get that value. That helps sell it not only to the people that have to embrace the change, but also to the leadership that has to write the checks for it. And so they see that sunk cost initially. We prove out some value, and then we have money to proceed to the next phase. And so it becomes just that investment go do strategy of, we'll make and go. And so everyone's journey is different. Not everyone has that big oil money to go all in all at once. And so there are companies that will take years, if not a decade, to say, okay, we've established our data foundation, we've understood how it relates to each other, we've solved these problems, and we're doing really well, but we think we can get this much more. We have this pump or asset that's not performing the way it should. Let's invest now in these predictive technologies or the AI tools to bring it all together. And by the way, our remote system, we don't have the support system we once did. our resources all sit offsite at some corporate location. How do we share that data? And that's kind of how the system just grows organically as the needs change and as the um, desire really changes.
Yeah, makes sense. And I like what you said about, establishing the data foundation, right? If you need to start somewhere. And this is something I talk to companies about, and a number of facets of the transformations that the industry is going through, right? Because we've got a number of transformations taking place at the same time: digitization, sustainability, et cetera. It's like, start somewhere. You figure out what your foundation is, establish your foundation and your baseline, and then you keep moving. So I'm going to use that to segue into ESG and sustainability, right? So ESG and sustainability, key themes we talk about a lot on the Chemical Show. It is everywhere you look at when you turn on the news or talk to people. What does this mean to AVEVA and its customers?
Well, I've talked at length with my boss, and he's a tad older than me and been doing this a little longer. But we came to the conclusion that these tools have always supported sustainability. We just called them something different. So whether it's reliable supply, asset reliability, waste reduction, energy management, compliance, we just never had that umbrella term before. Sustainability, and sustainability, of course, encompasses more than just those basics. Those are as my wife might say, table stakes. But we have these net zero initiatives out there for carbon reduction. Circularity is a very new burgeoning technology where we're taking these products, recycling them back into our value chain, right? So, and it's no longer just mechanical recycling; it's chemical recycling, bringing it back to the raw materials so that we can make something new again. And so that, I think, is where the forefront of the technology is really changing to adapt. We still do all the basics of monitoring and maintaining optimization and performance. So your energy management translates to emissions, safer operation. We don't have those aha releases that we may have had in the past. Our equipment's lasting longer. We're taking care of it better so that we don't always have to go and junk that pump. It lasts longer. We rebuild it. The wear and tear is not as bad as it once was. So we're operating in a more sustainable manner. Companies are changing their assets out to be more environmentally friendly in that regard, whether it's carbon capture or scrubbers or things like that. How do we monitor and optimize those systems? A lot of talk has been given to scope 1, scope 2 emissions, and that's really our bread and butter of optimization as engineers and the data systems we have today. I think what you're going to start seeing now is that community of data, and we'll jokingly call it the carbon chain, but the scope 3 that is everything else. Our suppliers, our customers, how that carbon emission is managed across our value chain, and being able to share that data and access it across those different legal entities in a safe and intellectual proprietary way is really going to be that next horizon for cloud data, and how we manage it will access through the AI and being able to capture those components and really prove that, hey, we're not just talking about it, we're actually doing it.
Yeah, that's really interesting. I think your point about the data, the community of data, becomes really critical for the industry, particularly as we look at scope 3, because scope 3 is the biggest impact that many companies and value chains have. So it will be good to see how this evolves and transforms.
And we've done it for years from that optimization standpoint. You're seeing these solutions begin to get baked in. From an engineering side, looking at our simulations, these emissions now are part of the model, right? So the greenhouse gas calculations you design it, these models are going to take a stab at what your footprint is. Planning tools where we, look at how we're going to manage our raw materials now include not only raw materials, but some of these greenhouse gas calculations and what power sources you're going to use. So your carbon footprint and the pricing model can change whether you're using, the coal-fired, coal generation electricity, wind, other renewables, so that, all that comes to play is how you run your business. And I think that's that baked in awareness to sustainability is really what's being developed now.
Right. And the digital assets help drive that transparency and information and decision making.
And so that back to the digital twin, connecting the dots from that simulation and model to your real-time performance to your planning and optimization expectations, allows that seamless communication of information. And then because it's a digital representation, hopefully we scale out to more and more facilities and across that business community.
Yeah, awesome. That's very cool. So, Stephen, this has been really good and interesting conversation here. What's next for you and for AVEVA as we play out the rest of 23 and into 2024? What should we be looking for?
Well, for me, I enjoy the work. I enjoy the job. I'll continue to be an evangelist for the operational excellence and digital transformation. As I tell my customers, I no longer have a plant of my own. Please allow me to help with yours. So I'll keep on keeping on. For AVEVA, I think you'll continue to see development across our portfolio. We're coming together as a one AVEVA now, trying to de-silo some of our toolkits and portfolio items. So I think you'll see tighter integration across not only our suite of tools, but into that value chain. The next frontier, of course, is cloud and AI. So you'll continue to see developments growing there, not only through our foundation, but through our technical partner sphere. And then, the next thing, I would invite everyone, if you're interested in AVEVA portfolio and the tools that we can offer, AVEVA World's coming up in San Francisco in October. So welcome to join us there and come see what new releases are on the horizon and where we're headed.
Yeah, awesome. Although I got to say, Stephen, it's going to be a tough decision because the Chemical Summit overlaps with the AVEVA World, as we know. So maybe people can tag team, go from one to the next. So Anyway, well, good.
That's right.
Well, thank you for this. I really enjoyed our conversation, and I appreciate you joining us today.
Victoria, thank you for your time, and thank you for the opportunity to speak.
Absolutely. And thanks, everyone, for listening. Keep listening, following, and sharing, and we will talk to you again soon.
We've come to the end of today's podcast. We hope you enjoyed your time with us and want to learn more. Simply visit thechemicalshow.com for additional information and helpful resources. Join us again next time here on The Chemical Show with Victoria Meyer.